plus t e to the t. So there's your y. Okay. Now we gotta get x, right? Will be function. Okay, what was it? When we started this thing, it was second order. We already have two arbitrary constants, right? So when we get x, we better not pick up another constant. Okay, what's the easiest thing to do to get x? Okay, you don't want to do this guy because then you have to integrate, and it's a non-homogeneous equation. Just look at this equation over here. Gives you x directly in terms of what you just found, right? X in terms of y and y dot. Okay, we'll call that equation number 2. Okay. So from the second equation, everybody understand, it's very important to understand why I'm using a certain equation. Okay, I want to make the life easier for myself, okay? And also I want to I don't want to introduce another arbitrary constant, okay? Much easier to take this equation and just calculate x directly from y and y dot than to go over here to an integration. You'd have to do a variation of parameters again, all over again, and worse, you'll pick up another constant when you do that. Okay, so from equation 2, x is 3y minus 2y dot. Okay, I'm not going to bore you with the algebra, right? Here's y. You know what y dot is, okay? You do 3y minus 2y dot, and then you simplify, and I'll give you the answer for that. What do you get for x in this case? You'll find out that when you solve for x, you'll get c1 e to the t minus c sub 2 e to the 2t plus t e to the t minus 2 e to the t. Okay, so there's your solution for x. Okay? So you got your solution for x, and you got your solution for y. And again, I guess I didn't mention this, you can check this, right? You can basically, did I do it right? Did I make an error? You can, it's funny how the check, I think, involves more algebra getting the solution. You take this x and y, and if you didn't make an error and you plugged it in, you'd see that you satisfies these two equations identically. Okay? I wouldn't recommend doing that unless you had time on a test, you got 10 minutes left, you say, okay. But again, if you're doing this, not in a test environment, then you want to know if you got the right answer. It's very easy to check that. And I think this may be the last one before the application. Yeah, okay, good. So it worked out fine. Okay, example 4, I say for the last, and it's going to, so far, notice that all the equations, we determined what the order is, we wrote down how many arbitrary constants were in the solution, everything went smoothly, where you never had to introduce another constant. The problem I'm going to give you now, there's no way of avoiding doing a second integration. And then we're going to pick up a constant which is superfluous, so to speak. Can't make it equal to 0, okay? And I'll show you how to get rid of that constant and get it in terms of the number of constants dictated by the order of the system. Okay, sometimes, it happens that this happens,
Meaning you're forced to integrate.
You're forced to integrate, and then you say, wait a minute, I can't have 4 constants now. How are you going to get rid of that 4th constant? Okay, and it comes out, and you'll just have to plug into the other equation, and there'll be a constraint, I suppose. So again, the book doesn't talk about this, which I'm surprised, and kind of, the fact that this happens it should be surprising. It's like when you solve, back in high school, you had these equations, with radicals. Remember, you squared both sides and stuff. You get these extraneous roots. Because when you square an equation, you can introduce extraneous roots. When we take these equations, we hit this with a d plus 2 or these operators, we're differentiating. And we differentiate and lose information, right? You get more general solution than you started with. So it's not surprising that this will happen sometimes. But knowing right away how many constants should enter to the solution, you know exactly what you have to do. See, I'd have to go and check all these again. I know that they're right because the number of constants is right, and let's assume the algebra, was correct, and it's okay.
Yeah, I have a question.
Sure.
You said, so we know the number of constants, but is that going to be, like, say for the last one there's 2 constants, is that going to be in both x and y?
Generally, yes. Yeah.
Or is it just, could
No,
it be?
no. It's not like you'll get C1, C2, and X, and then C3, C4, and Y. In general, because the equations are coupled, okay, the constants will be smooth, they'll be all over the place.
Okay,
Yeah.
well, but could you have, like, x could only have 1 constant and y would have the same constant? Like, say we knew there was 2. Could it be x just have 1 constant and then y have 2 constants?
Yeah, sure. Yeah,
Okay.
yeah. For example, it's like the first order equation on X, and you integrate that first, you'll get 1 constant, and then maybe the equation on Y is second order, so you introduce 2 more. That's exactly the situation you said. Yeah. Okay. So here's the last example. Okay, so the first guy is dx dt plus the second derivative of y with respect to t is equal to e to 3t. Okay, first equation, dx dt plus that's the second derivative. Yeah, second y with respect to t. X dot plus second y with respect to t is equal to e to 3t. X dt plus x. Next equation, dx dt plus x plus dy dt minus y is equal to 4 e to the 3t. Okay, let me say it again. So the first equation is x dot plus y dot dot equals e to 3t. X dot plus x plus y dot minus y equals 4 e to 3t. Okay. So, what's the order of this system?
Third.
Third, yeah. Because on X, all I see is the first derivative, and on Y, I see the second, third. So basically, third order. Which means what? Means basically when we solve for X and Y, in total, I should just see 3 arbitrary constants of integration. No more, no less. Okay. First step is, just write in that notation. T on X plus t squared on Y is equal to exponential of 3t. Now I got, what's this, t plus 1 on x, right? Because I have x dot plus x plus t minus 1 on y. X dot plus x plus y dot minus y is 4 e to the 3t. Okay, let's just see how do I do this? I eliminated the x. Okay, I'm going to eliminate x. Okay? Which means I got to hit this guy with a d plus 1 and hit this guy with a d. Okay? I guess I did that because I didn't want to see if I wanted to eliminate y, I'd have to hit this with d minus 1 and this with a d squared. So I was going to get the lowest order derivative just to save myself work. So, okay, so first guy needs a d plus 1, that's a d. Okay. And again, the operators commute, right? So is it d plus 1 d on x or d plus 1? It doesn't make a difference because they commute. So d plus 1 operating on x, right? D plus 1 plus d squared d plus 1. Operating on y. D plus 1 operating on e to 3t. And again, I remind you of the power of this notation. D plus 1 operating e to 3t basically is a shorthand for the derivative of e to 3t plus e to 3t. Okay? Hit this guy with the operator d, which means just differentiate. I get dt plus 1 on x plus dd minus 1 on y. Equals the derivative of 4 times the derivative of e to the 3. take these equations and I subtract, right? Okay, the dd plus 1x goes out. Let's just be careful over here. I've got d squared times d plus 1 operating on y, right? Minus dd minus 1 operating on y. D squared d plus 1 on y minus dd minus 1 on y equals, what's d plus 1 minus 4d? That's just 1 minus 3d operating on e to the 3t. Right? Okay. Let's see what happens over here. D squared d minus 1 gives me a d cubed plus d squared minus d squared, right, plus d, that's operating on y, equals d cubed plus d squared minus d squared plus d. Okay, and let's just work this out. What's 1 minus 3t operating on e to 3t? It's basically 1 e to 3t, which is e to 3t, minus 3 times the derivative 3t, which is 3 e to 3t. Which is e to 3t times 1 minus 9, which is minus 8 e to 3t. Okay? So, let's just write this in our normal notation. You see how the d squared's knocked out, right? So we get d cubed plus d. Well, that's really just the third derivative of y with respect to time, right? It's d cubed on y plus dy dt. D cubed plus dy dt equals minus 8 e to 3t. D cubed plus d operating on y minus 8 e to 3t. Okay. Third order differential equation. Okay, let's get the solution of the homogeneous equation. Okay. Well, that means it's third derivative expect t plus dy dt is equal to 0. The characteristic equation is what? R cubed plus r equals 0, which is really r parentheses r squared plus 1 equals 0, right? And the three roots are r equals 0, and then plus or minus r. Okay. So, what's the complementary solution? The solution to the homogeneous equation. Okay, just use superposition. You get c1 e to the 0t, which is just 1, right? And then I got sines and cosines, right? Plus c sub 2 sine t plus c sub 3 cosine t. That's the complementary solution. Now I gotta get the particular solution, right? I'd like to finish this. So if we go a little, hopefully I'll finish it. Maybe I'll go 2 minutes, 3 minutes over a little. Okay. So the particular solution. Okay. So you look at the right-hand side. What's the family of minus 8 e to 3t? It's just e to 3t. Luckily, e to 3t is not a homogeneous solution, right? So the particular solution, y sub p, is just some constant e to 3t. Okay. And now we go through the algebra. You just do the thing and you solve for a, and you'll find out that, okay, you find out that a comes out to be minus 4/15. Right? Everybody knows how to do that, right? You just plug in yp dot, and you equate it. Okay? So, the solution for y of t can be written as c1 plus c sub 2 sine of t, right, plus c sub 3 cosine t is the complementary, right? And then the particular looks like minus 4/15 e to 3t. So far, so good, right? Now let's go back to our equations and see what's the easiest way, given y, how can we solve for x? Okay, well, we have y, okay, so I can bring that to the other side. dx dt I gotta integrate. If I integrate though, I introduce another constant of integration. Okay, how about the second equation? That's even worse, right? Not only to get constant integration, I also have to solve an inhomogeneous equation, right? So let's take the first one and integrate to find out what we get, okay? And then the question is, what we're gonna do with that c sub 4 that we're gonna come up with. Okay. I chose to do this one, right, number 1. I got y, so I just do x dot. Okay. So, from equation 1, we find that dx dt is e to the 3t minus y double dot. Okay. X dot is e to the 3t minus y double dot. Okay? And then if we integrate that, we find that x is equal to a third e to the 3t. Okay? Minus dy dt plus an arbitrary constant c4. Okay? There's no way out of it. We got it. So that's what's going to happen. Okay, I won't do the algebra basically. You have y of t over here, right? Then you get y dot, and then you just integrate that. And let me show you what happens for x of t then. Okay? You'll find that x of t is minus c sub 2 cosine of 2t plus c sub 3 sine of t plus 17/15